I'm trying to build a rainbow, but I'm not sure I've got enough bricks of each colour. To check, I could go through, select all the red bricks, and count how many of them there are, and repeat this with the orange, yellow, and so on. But this is tedious. Luckily, SQL can do this all for you. Enter the world of aggregations. Aggregate functions combine values from many rows and output a single row. These enable you to do things like count how many rows you have, find the smallest and biggest values in a column, or the total sum of all the values. Most aggregates accept a column as an argument, but count is slightly special. You can pass a column to it, which gives you the number of non-null values in that column, or to ensure you get the total number of rows, use star. They also allow you to prefix the column with the keyword distinct. This first filters your dataset to find the different values for the column. Once it's done this, it then applies the function to one instance of these values. For example, I've got 4 bricks here. If we count them, the total's 4. Also, if we count the colour, that's 4 too. But there are only 2 different colours, so if we count the distinct colours, we only get 2. Similarly, these 2 bricks are the same size and same weight. So if we were to count the distinct weights of these bricks, we'd effectively only get the weight of 3. Count, sum, min and max are some of the most common aggregate functions you'll use, but there are many more available in Oracle database to aggregate your data. For a full list, check out the links down in the description. Or if you have unusual requirements that these don't cover, you can always write your own. So, to check how many bricks I have available, I can run a count. But this gives me the total number of bricks. I need the number for each colour. I could run a separate query for each colour to find out how many there are, but this is a lot of work. Fortunately, there's a shortcut. You can get the totals in a single query using group by. This splits up the results according to the values in the group by column. You'll get a row in your output for each different value in it. So a count group by colour will give you the number of different bricks of each. You can group by as many columns or expressions as you want. Doing so further subdivides your results, giving you the totals for each set of values in the table. This is great because I can check if I've got enough bricks of the correct shape and colour to build my rainbow. But if you want to know how many bricks there are of each colour, regardless of shape, you have a problem. Either you can count these manually, or run a separate query getting just the count by colour. Once again, SQL comes to the rescue with roll-ups. You place this in your group by and then put your columns within it. This then calculates the subtotals, working from right to left through the columns. If all the grouping columns are in your roll-up, it also gives the grand total. If you want the subtotals for every column in the group by, use cube instead. When grouping, columns in the select must either be in the group by clause or have an aggregate function applied. But the reverse isn't true. You can group by columns not in your select. This can get confusing, so in most cases, copy your group by clause into the select. So, I've grouped my bricks by colour, but I'm still not sure if I've got enough of each to build my rainbow. I need at least 10 of each colour to do so. To find which we've got enough of, you may be tempted to do this filtering in your where clause. But databases group rows after the where clause, so this doesn't work. What you need to use instead is a having clause. This filters the data using the result of your aggregate functions. So, to see which colours you've got enough of, add having count star greater than or equal to 10. Before we finish, it's important to remember that grouping and aggregation reduce the rows in your output. But sometimes you want to see all the table data and the count. You can do this by converting your aggregate to an analytic function by adding the over clause. But More on that another day. So we've looked at how you can select, join, and aggregate data from your tables. But this is no good if your tables are empty. We'll look at how you can add data in the next episode.